Okay, so I have opened up a new model of VenSim, and that's because we're going to do a slightly more complicated model. I'm assuming you've watched my introduction videos, so you know how to create things like level variables and flows and rates. So we're going to start a new model. We're going to leave everything alone for the moment. And the model we're going to create today is a more advanced population model. So we need a population level variable, and we need a flow or a rate. And for this model, we actually need two variables. We need a constant of proportionality, and then we also need a carrying capacity. And carrying capacities are something that you should learn about in class and also from the homework, but that's what we're going to use. So again, we're going to need an arrow to go from our proportionality constant into change in population, also one from our carrying capacity, and last but not least, our population. I want to point out a couple of things. You can move these arrows around by clicking on the little tiny circle in the center. If you use the hand, you can move the flow as well if you want. I don't know why you would. And then you can, if you right click on the ends of your rates, you can do things like change the color, the background color, change what you want for arrows, that kind of thing. So for example, this color is black. I can make it orange if I want. And so now all my letters in orange, which is kind of annoying, but I'm going to leave it. All right, so we have our diagram of our model, and now we need to start putting in the equations. We're going to have our constant of proportionality again being 10%. We'll go with rats again, no particular reason. So 1 per day for the constant of proportionality. Our carrying capacity is, say, again, it's going to be in rats. And let's see, we have a carrying capacity of 1,000 rats. Our population, how many rats are we starting with? 10. Remember, don't change the thing in this box. Leave it alone, but you do want to change your units. So we have rats. And then last but not least, we need to put a formula in for change in population. And the model we're going to use is the logistic model. And that says that the change in population is proportional to the population. So I need a multiplication sign times, and this is the extra step. This is where we say, well, we want it to be exponential when population is small, but we don't want it to get too big. And so we're going to put in 1 minus our carrying capacity. Oops, not our carrying capacity, that goes at the bottom. Our population divided by our carrying capacity. Close parentheses. If you don't do that, VenSim will complain. So again, looking at our model for a second, this term is constant. This is just our population. And then this fancy term, when population is small, is going to be about 1. So when population is small, it's going to be our traditional exponential growth model. But when population is close to m, this population divided by m is going to get close to 1, and 1 minus that is going to get close to 0. And that's going to allow us to slow down when our population gets close to m. Our units are going to be rats per day. And we know that because the units of k are in 1 per day, and the units of population are in rats, so that's going to be rats per day. And then you would think you might have some unit problems here, but because the units of population are in rats and the units of m are in rats, we get rats divided by rats, or just a dimensionless constant there. So that looks good. The only thing we're going to have to do is, because our units of time are day, we're going to go back and we're going to go up and change our model settings. Sure, I'll save it. I'm going to call it something like test 2. You can call it whatever you want as long as you can find it. So again, we want our time units to be days. So looks good. If we want to check everything, we can do a units check. And it says the units are okay, which means that VenSim goes through and checks that this is in population per day and this is in population. So we're good. Let's run it. And if we graph our population, we see our classic logistic growth curve where the horizontal axis is time in days and the vertical axis is in rats. So that's what we expect to see. If we were curious, we could graph the population and the change in population. I just did that by, let me do that again. I click on population and I'm going to hold down the shift button and click on change in population. That's going to grab both of those. I can graph those and you can see that our rat population in red, and then our blue is our change in rat population. And so we can see that it peaks right here just about the time when this red population is growing the fastest, which is what we would expect to see. So there you have it. It's a logistic growth model with a few extra things thrown in. At this point, you should be able to go back and look at all of your homework and recreate any of your homework problems in VenSim. You will be expected to do that by the next test. Thank you.